Hello everyone, today we'll be going to kinetic theory. Yes, kinetic theory, yes. Can you just click on the subscription button before we go? It's Chem Classroom with Auntie Taiwo. So we are entering into the calculation aspect gradually. Okay, so today we'll be talking about some gas laws. Before gas laws is your kinetic theory, whereby we talk about our gases, that the movement of our gases move in random motion, colliding with the walls of their container, and that they exhibit some kind of collisions and all that. So today we'll be going to Boyle's law. We have about we have about 6 gas laws. We have the Boyle's law, we have the Charles law. We also have the general gas law. Of course, it's a combination of the Boyle's law and the gas law. We have the ID gas law. We have the ID gas formula. We have Dalton's law of partial pressure. We have the Avogadro's law. We have Gay-Lussac's law of combining volume. We have Graham's law of diffusion. So we have about 6 to 7 of them, and they all have calculations. And so we are going to take them one after the other. So today we'll be going to Boyle's law. Boyle's law states that the volume of a given mass of gas is inversely proportional to the pressure provided temperature remains constant. So we are not going to start to prove any formula. I'm just going to give us the formula directly, and we'll go to do the calculation on the board. Okay, so the formula for our Boyle's law is P1V1 equals to P2V2. Yes. Okay, so under the Boyle's law, our temperature is constant, so we are not going to relate it to temperature at all. We are just going to deal with our pressure and our volume. Okay, now somebody will ask me which one is P1, which one is P2, which one is P1, which one is V2. Now it depends on how the question is being arranged, but the first pressure that is being mentioned is going to be our P1, while the first volume that is mentioned is going to be our V1, while P2 is the second pressure in the question, while V2 is the second volume in the question. So, and I like to write out the parameters so that we don't get confused along the line. Okay, so the question says a given mass of a gas occupies a volume of 300 cm cube at what? 900 millimeter mercury. Now for our volume is measured in what? Cm cube. But for our pressure can be measured in about 3 units, yes, or at times 4. Our pressure can be measured in what we call the millimeter mercury. Pressure can be measured in Newton per meter. Even our pressure can be measured in Pascal, although most times we don't use that Pascal. Then our pressure can be measured in atm, which is the atmospheric pressure. So anytime you see any of these units, pressure should come to your mind. So calculate the volume occupied by the same gas at 750 millimeter mercury if the pressure remains constant. Okay, so my P1 is going to be what? 900, because that was the first one that was mentioned. My V1 is going to be what? 300 cm cube. Then calculate the volume. So that means I'm calculating for V2. V2 is what I'm looking for. Then P2 is what? The second one is what? 750 millimeter mercury. So let's apply our formula. P1V1 equals to P2V2. So, and I'm looking for what? V2. So I'll make V2 the subject of my formula. So my V2 is going to be what? P1V1 over P2. Okay, so my P1 is what? 900 times what? 300 over 750. So my final answer here is expected to be what? 360 cm cube. Please always remember to write your unit at the end of the question, at the end of the